Hello students, today we are going to study very important topic for JEE and NEET, that is thermodynamics. In thermodynamics we will study about various types of thermodynamic system, zeroth law of thermodynamics and first law of thermodynamics, various temperature measuring scales and various types of thermodynamic processes and how to calculate work done by gas, that we will see here. So dear student, there are three types of thermodynamic system, that is open system, closed system and isolated system. Okay. Open system means when mass and heat both can be exchanged. In case of open system, neither mass conservation nor energy conservation is applicable. Okay. Neither mass nor energy conservation is applicable. In case of closed system, for example, this is a glass bottle. So heat exchange is possible, but mass exchange is not possible because this is a closed bottle. Okay. So here in the case of closed system, principle of conservation of mass is there. Principle of conservation of mass is applicable, but principle of conservation of energy, principle of conservation of energy is not applicable. While in case of isolated system, both mass and energy conservation is applicable. Both mass and energy conservation principle is applicable. These things will become very important while solving numerical problems. Okay. In isolated system, both mass and energy conservation principle is applicable. Mass conservation means mole conservation. Okay. Energy conservation means total energy. Okay. And in case of closed system, only mass conservation principle remains applicable, but energy conservation principle is not applicable. Okay. While in case of open system, neither mass nor energy conservation is applicable. So dear student, let's see about zeroth law of thermodynamics, first law of thermodynamics, work done and application of first law. The zeroth law of thermodynamics defines the temperature. It defines the temperature and various temperature measuring scales are prepared. And what is zeroth law of thermodynamics? Let's see here. If there are three bodies, if body A and body B is in thermal equilibrium and body B and body C is also in thermal equilibrium, then dear student, body A and body C will also be in thermal equilibrium. This is called zeroth law of thermodynamics. Okay. What I told, when body A and body B is in thermal equilibrium and body B and body C is also in thermal equilibrium, then body A and body C will also be in thermal equilibrium. Okay. That is called zeroth law of thermodynamics. Dear student, zeroth law of thermodynamics defines the temperature. Okay. Zeroth law, it defines the temperature. Now I am telling you the concept of making various temperature measuring scale. Okay, that is very important. Okay, various temperature measuring scales. The concept behind every temperature measuring scale, that lower point of every temperature measuring scale is the melting point of ice, and the upper point of every temperature measuring scale is the boiling point of water. And what is the principle? The principle is that in all temperature measuring scale, name of the scale minus lower point divided by upper point minus lower point. This factor is constant in all temperature measuring scale. Okay, on the basis of this factor, temperature measuring scales are designed. Name of the scale minus lower point divided by upper point minus lower point. Okay, this is the key concept behind making every temperature measuring scale. We will look some temperature measuring scale like Celsius scale, Fahrenheit scale, Kelvin scale, okay, Roman scale, and even you may design temperature measuring scale on your name. Okay, let's see. Once you have seen the basic concept, now you can design, you can talk for any temperature measuring scale. Dear student, this is a Celsius scale. On Celsius scale, lower point is 0 degree centigrade and upper point is 100 degree centigrade, and number of division are 100, means each division is equal to 1 degree centigrade. Each division on Celsius scale is 1 degree centigrade. More is the number of division, lesser will be the value. Okay. Now, dear student, let's talk about the Kelvin scale. On Kelvin scale, again number of divisions are 100. The lower point is 273.15 Kelvin and upper point is 373.15 Kelvin. And here also number of division 100, means one division on Kelvin scale is equal to one division on Celsius scale. That indicates what? If you make the difference of two numbers, okay, two division, then difference of two number on Kelvin scale and difference of two number on Celsius scale, that will remain same. So delta C, change in temperature on Celsius scale, will be equal to change in temperature on Kelvin scale. Okay, that's very interesting. Now, dear student, let's see. This is Fahrenheit scale. Here number of division are 180. Lower point is 32 degree Fahrenheit and upper point is 212 degree. Upper point is 212 degree Fahrenheit. Number of division are 180, means what? Dear student, here one division is lesser than here one division. Okay, more is the number of division, lesser is the value. Okay. Now let's talk about the Romer scale. Lower point is 0 and upper point is 80. Number of division 80. And dear student, final talk for unknown scale. Okay. Here let us assume lower point is x and upper point is y and name of the scale is p. Okay. Name of the scale is p. So dear student, now we can relate the relation, okay, on the basis of the general concept. What is general concept? Name of the scale minus lower point divided by upper point minus lower point remains constant in all the scale. Okay. So let's see. Celsius scale minus 0 divided by 100 minus 0. Fahrenheit scale minus 32 divided by 212 minus 32 divided by Kelvin scale minus 273.15 divided by 373.15 minus 273.15 divided by R minus 0 upon 80 minus 0. P is the name of the scale, X is the lower point, Y is the upper point, X is the lower point. Okay. So dear student, now we can make suitable relation. There are some important points. C upon 5 equal to F minus 32 upon 9 equal to R upon 4. This is one relation. And now second relation, delta C equal to delta K. Third relation, delta C equal to delta F 5 by 9. Fourth relation, 8 minus 40 degrees centigrade, Celsius and Fahrenheit are same. Okay. So the dear student, these are some relations. Okay. Now if any one question is asked, you can easily solve by using these equations. Okay. Now we will talk about the first law of thermodynamics. Okay. Dear student, first law of thermodynamics is based on principle of conservation of energy. First law of thermodynamics is based on principle of conservation of energy. In this chapter, we will see what is work, calculation of work done by gas, and what is first law of thermodynamics, and what is application of first law of thermodynamics. Okay. In any thermodynamic process, work is defined as area under pressure volume curve bounded by volume axis. In any thermodynamic process, work done can be defined as area under pressure volume curve bounded by volume axis. Okay. This is how we define the work in any thermodynamic process. Now, if we talk about first law of thermodynamics, first law of thermodynamics, it is based on principle of conservation of energy. Now, dear student, what is general statement of the first law? Let's talk about this is thermodynamic system. Okay. This is the boundary separating the thermodynamic system and environment means surrounding. Dear student, if we supply the heat to the system, heat supplied to the system in numerical problem is taken as positive. Heat supplied to the system in numerical problem is taken as positive, and heat extracted from the system in numerical problem is taken as negative, okay? And dear student, work done by the system means if volume increases, work done by system is taken as positive, and work done on the system is taken as negative, okay? If internal energy of the system increases, it is taken as positive. If internal energy of the system decreases, it is taken as negative. And the general statement for first law of thermodynamics is delta Q equal to du plus delta W. Very important thing here is Q and W means heat supplied and work done. Q and W, these are path dependent quantities. But internal energy of the system, this is path independent. This is path independent quantity, okay? Internal energy of the gas depends only on the initial and final position of the system. Internal energy of the gas depends only on the initial and final position of the system, okay? Now, dear students, we will talk for work done in many thermodynamic processes. Let's start from the isobaric process, okay? Let's start from the isobaric process. We are calculating work done by system means by gas, and simultaneously we will apply first law of thermodynamics also. We are starting from isobaric process. Dear student, isobaric process is a process in which pressure of the gas remains constant. And this is the general graph for isobaric process. This is volume. Now let's talk for the gas volume. Let us talk that gas volume is increasing. If initial volume of the gas is V initial and final volume is V final, initial temperature is T initial and final temperature is T final, we have already seen work done by the gas is what? Area under PV curve bounded by volume axis, okay? So what is work done here? In this case, work done by gas is PV final minus V initial, and what is ideal gas equation? PV equal to nRT. N is number of mole. This is nRT final minus T initial, okay? This is work done by system means work done by gas. You can see here, if volume increases, work done by gas is positive. If temperature increases, work done by gas is positive. Okay. So dear student, this is the way to calculate work done by gas in a isobaric process. Now if we apply first law of thermodynamics to isobaric process, what is the equation? See here. Dear student, this is the heat supply delta Q equal to du plus delta W. Du is internal energy. This is general formula NCV delta theta, and delta W is PdV. This is NCV delta theta plus P delta V NR delta theta. If we take N common, CV molar specific heat plus R delta theta, and this is called NCP delta theta. Dear student, I am telling you about CP and CV. CP is molar specific at constant pressure and CV is molar specific at constant volume. Dear student, CV is what? F by 2R. F is degree of freedom. This we will see later. And CP minus CV, difference of molar specific heat equal to R. This is called Mayer relation. This is called Mayer relation, and this is a constant, okay? Dear student, remember one very important thing, difference of specific heat, Cp minus Cv. This is difference of specific heat. It is not constant. It depends on the molar mass, okay? But difference of the molar specific heat, it is a constant, okay? This is molar specific heat. This is a constant for all gases, okay? So this is the heat supplied to the system in a isobaric process, Now let's talk about the isochoric process. Isochoric or isometric. Isochoric or isometric process is a process in which volume of the gas remains constant. If volume is constant means what? Change in volume is zero, means work done is zero. Dear student, in an isochoric process, work done by gas is zero, okay? So if we apply first law of thermodynamics, we will get delta Q equal to du plus delta W. So what is the equation we are getting? In an isochoric process, heat supplied to the system is equal to increase in energy of the system. In an isochoric process, heat supplied to the system is equal to increase in energy of the system. Okay? Means if we are supplying heat, temperature of the system will get increased. General equation of U is F by 2 nRT. So general equation of du is F by 2 nR dt. This is general equation, okay? du can be written as NCV delta theta or delta t, same thing, okay? Now, dear student, we will be looking for work done by gas in a isothermal process. Work done by gas in a isothermal process. Is the name indicates isothermal process means the process in which temperature remains constant, okay? The equation of state for isothermal process is PV equal to constant. And the slope of the curve dP upon dV equal to minus P upon V. If we talk about the work done, the graph for isothermal process between pressure and volume is a rectangular hyperbola. The graph is rectangular hyperbola. If we talk about the work done by gas, in isothermal process, dear student, this is 2.303 nRT log 10 V final upon V initial. And since process is isothermal, so PV equal to constant, P initial, V initial equal to P final, V final. So we can write 2.303 nRT log 10 P initial upon P final. This is the work done by gas, okay, in a isothermal process, okay. So dear student, this was the work done, okay. Now let's talk about the adiabatic process, okay. Adiabatic process are the process in which delta Q is zero, neither heat goes out from the system nor heat comes inside the system from outside, okay. So delta Q remains zero. The equation of state for adiabatic process is PV gamma equal to constant. And what is gamma? Dear student, gamma is ratio of molar specific heat at constant pressure and constant volume. This is equal to Cp upon Cv. It depends on the atomicity of the gases. For monoatomic gas, monoatomic F equal to 3. So gamma is what? 1.67. For diatomic gas, degree of freedom is 5. So gamma equal to 1.4. And for polyatomic gas, There are two types of structure, non-linear and linear. For non-linear, degree of freedom is 6. Here it is 5. So dear student, gamma is what? 1.33. Here gamma is what? 1 plus 2 upon f. Again 1.5, 1.4. If vibrational degree of freedom are also taken into account, here degree of freedom are 7. Okay. 3 translation, 2 rotation, and 2 vibration. Okay. And here what is the picture? Here 3 translation and 3 rotation. Here all the 3 are translational. Here what is the picture? 3 translational and 3 rotational. Okay. Now dear student, let's talk about the work done. First write the slope. Slope of adiabatic curve equal to minus gamma P upon V. Means slope of adiabatic curve is gamma times slope of isothermal curve. So dear student, adiabatic curves are more steeper than isothermal curve. Okay. Adiabatic curves are more steeper than isothermal curve. If we talk for 2 curve, which curve will be adiabatic? This is adiabatic and this is isothermal. Okay. Now dear student, we are writing for equation for work done. Work done in adiabatic process. This is equal to NR upon gamma minus 1 T initial minus T final, or 1 upon gamma minus 1 V initial minus P final V final. This is the equation for work done by gas in a adiabatic process. Okay. In case of cyclic process, dear student, change in internal energy remains 0 and work done by gas equal to area enclosed by loop. In this case, it is positive because volume is increasing. You will see from the top. If volume increases, you will take this to be positive. So what is here? Delta Q will be equal to delta W. And in case of free expansion, everything will be 0. Du will be equal to 0. Delta W will be equal to 0. Delta Q will be equal to 0. So dear student, this was all about the general equations of work done in a thermodynamic process. Okay. In the next lecture, we will be seeing the numerical problems associated to the how to calculate work done. Okay. Thank you very much.